Good morning, gentlemen. At the end of this class, you should know how to construct a normal, tangent, and find focal point for an ellipse. Uh, what are focal points and how do we find focal points? See, for example, this is our ellipse, and for this, I'm establishing my vertical and my horizontal center line. This is my minor axis, major, join here to there. That's my first quarter. From here to there, that's my second quarter. Here to there, third quarter. And from this point down, fourth quarter. Now, say for example, I wish to find my focal points and to draw a tangent from a point here. This is my tangential point, which I'll label P, point P. The first step is to find the focal point. How do I find focal points? We establish our focal point by opening our compass to half dimension of the major axis. Here, there is our major axis. Let's use a dimension of 100 millimeters for our major axis. Let this be 100 millimeters. And our minor axis, for that, let that be 60 millimeters. $60 millimeters. The first step is to open your compass to half the major axis. In this case, the major axis would be 50 millimeters. The next step is to use this point as center, with this point as center, and radius be half the major axis, which would be from this point to this point. Scribe an arc. Here a center, scribe an arc to cut the center line at 2 points. At the points where the arc cuts the center line are our focal points. So one focal point would be here. Let's label this F1. F1. Second focal point would be here. Again, we label that F2. So there is our focal point 1 and focal point 2. So let me just repeat that. To find the focal point, you must open your compass or draw an arc having a radius half the distance of the major axis. Next, using this point as center, scribe an arc to cut the center line at 2 points. Once you have done that, the next step is to find our focal point. Our focal point is formed by bisecting the angle that is formed between F1, point P, and F2. It means therefore that I'll need to join those points. So I join F1 to point P and F2. An angle is formed here. The normal is the bisector, of that angle. And for AutoCAD, we can use uh, X line. We can use X line to bisect the angle that is formed here, or we can use um, some other geometric technique to do that. All right. To do that, I'm going to use X line. I think X line is easier. So I would type XL, enter, XL, enter, X line. It will then ask you to to identify the vertex. The vertex is a point where the angle is formed, which is here. Next, you would click F1 and F2, and automatically it will generate the angle here. It will generate an angle here. So this would be our normal. To find the tangent is perpendicular to the normal at this point. So to do that, to find the tangent, to find the perpendicular to this line, that can be done again using several commands. We can construct a perpendicular line to this line. We could rotate, we could draw a line from here, we draw a line from here to this point, then apply a rotate command, rotate with copy, RC, then for the angle we enter 90 degrees, and that will generate the perpendicular here. That's one way of doing it. We could also draw a random line somewhere, draw a random length line somewhere, and use a command called geometric constraint. So we type GC tangent, GC tan, and that will generate the GC tan. Then it would select this, then this line, and it would automatically rotate this line perpendicular. Then we can grip this and move it into place here to get a tangent. We could also use line, shift right click, hold on shift right click, and select perpendicular. Then we click here, then draw that line. All right, enough for talking. It's now time for us to create some action. All right. Any question, guys?
No, sir.
Okay.
So, sir,
Yes, son.
once we identify the point that them asking us to find the focal point, we use half of the length of the
The
diameter, or the
major
major
axis,
arc,
yes. It has to be
axis,
the major axis, yes.
and create an arc from the
Um,
top of the ellipse, and
yes,
where the arc bisects the center, the
yes,
line in the middle. Yeah, those are the two focal points.
yes, exactly,
Then you
exactly.
form the angle. Use
Yes,
the the X line command to create the line, and
yes,
then we use one of the methods you listed below to create a tangent at that
yes,
point. Okay,
exactly.
sure.
Yeah,
Let me
great.
try.
Yes, sure. All right. I will be doing some drawing now. All right. I will be doing some drawing now. All right. Um, I will need a screen space. I will need a screen space. I will have to remove this. All right. So the first thing to do here, if you have a ellipse, you can use it. The ellipse that we did last class. By the way, for persons who don't have AutoCAD, you may want to draw this using pencil. All right. So the first thing is to engage my orthogonal, draw my horizontal and vertical datum line. For this, I engage line, first, second, enter. space bar to reactivate. I draw this line someplace like here, enter, click, move the middle mouse grip, move this to the center point, escape. Next, I change to my outline layer. My outline can use or construction line. I'm going for outline in this case. Next, I have choose to, I'm gonna create an ellipse, center, and from here, my center. For this, I want this to be 50, 50, enter. I want this to be using a diameter here of 60, let this be 30, 30, enter. So I pretty much use the command to draw this ellipse, right? So now that we have created the ellipse, the next step is to identify where we want our point to be. In some cases, or in most cases, they might give you a specific coordinate for the point. All right, they might give you a displacement, a location. It can be yes. It can be at let's say for example, the point is located 30. Want our point to be located 30 millimeters in this direction, 30 millimeters in that direction, and 20 millimeters upwards, 20 and 20 up, 20 up. So here is 20, here is 20, 20. So here our point would be here, and to generate our point, so here is what did I say, 30 here? Yeah, oh, 20 there, and let this be 20 there, and let this be about 40 on this plane. So this is 40 on the x-axis and 20 on the y-axis.
Well, that's where we must put our point.
Yes, I'm using that,
okay, sure.
For my point. And for persons who are drawing, adding some dimension to this. Linear start point here. Okay, now that you have dimensioned this, and we have established the location for our point. To get the point officially, we can type POINT, POINT, enter, and let's say the point is here. Let's say the point is here. All right. The point might not be visible. Point might not be visible. So let me type DDP, type DDP, TYPE, enter. All right, PTYPE, enter. And I select this, set this to set absolute size. And see, this has moved to the center point right here. So guess what? I could move this point. I'm going to move this point from here, 40 millimeters to the left and 20 millimeters up. So I select move M, enter. I type D for displacement, enter. Then I select, I type -40, -40, comma, 20, enter, enter. You should be moving. Again, M, enter. Select object, select this, enter. Specify base, specify base point is here. 40, comma, 20, enter. See what happened? It moved. I should have entered -40. I entered +40, but it's okay. It's okay. That can work. So this move the point to this distance here. All right. We could also move that using another value. We could also use we could also offset those lines, like O, enter, O, enter, O, enter, offset distance 40, enter, select object to offset, click here, move in this direction, space bar, offset distance. We want this to be 20 up, so we type 20, enter, click this, and all right, so that will fall a little bit out of it, so move this to that point. All right, so that would have been our point. I don't need this anymore, delete. So now we have identified our point. The next step is to draw an arc having a radius which is half the diameter, having a radius half the diameter. For that, I could go to center, start, end, or I could even use circle. You click here, use circle, click here for circle. Radius in this case is 50, 50, enter. And here we have the focal points. One focal point here, next focal point there. But that I could also use text. So single line text. Click here. Here is, click here for start point. Text height 4, enter. Rotation angle 0, enter. F1, F1, come across here. F2, enter. I could throw off the excess by entering TR, enter once. Select cutting edge here, enter. Then touch the circle. Everything to the top will go. So now we have our focal point 1, focal point 2. The next step is to join F1 to point P. I need to copy this, I need to label the point also. But that's, I select copy, CO, enter, specify a base point here. Let this be, that be the point. I click 1, 2 times inside that to change that to P, P. Click outside, escape for that. Next, change to the outline layer, construction line layer, sorry. Click construction line, join from F1 to P, P to F1 to F2. Now we have created an angle here. The next step is to bisect this angle. All right, bisect, we use X line. Type XL, enter. Now it will give us 4 options: horizontal, vertical, angle, or bisect. click B or type or click B, bisect or enter B. It asks for the vertex, click here for the vertex, start angle is here, second point is here, enter. Now it has created the bisector. To determine where this line is infinite, is everlastingly long. To determine where we cut this line, we use a circle. Click circle, click here, then establish an imaginary line, something like that. Then we are going to trim off the excess. Radius of, say, 24, 25, enter. Trim, TR, enter. TR, enter. Select cutting edge, click there, press enter. Touch below, grip and hold, touch above, escape. Now we can delete this. Delete. And our normal is formed here. If you want your normal to be a bit longer, you could use a larger radius. In some cases, they might tell you what the length of this should be. If you wanted a length of, say, 100, you would draw a circle having a radius 50 millimeters, which would work out to the diameter. Then you would trim off the outside. To see the thickness of this line, I click line weight thickness. Now I wish to brighten up this here, so I type MA, match property, enter, click this, touch that, touch that, touch this, escape. Now I want to draw my tangent. My tangent should be perpendicular to the normal. All right, to the normal. For that, I undo. What I'm trying to do here is to extend this a bit. The next step is to draw a perpendicular line to the normal. To do that, click line. When it says specify the start point, I hold on the shift, right click, then click on perpendicular. I then move towards this line. You should see a perpendicular sign popping up. Click, then determine how long you want this line to be. Enter. Now click this line, grab and hold the middle mouse, move it to point P, click, escape to clear that. And now we have our normal and our tangent. To change this to an outline, we simply click MA, enter, click here, click there. You will realize that our tangent is on the wrong layer. To change that, I click, go to this, select dimension, and that has been changed. We also want to change this, click, construction, and that has been changed. So that is basically how you draw the tangent, or draw how to find the focal points, normal and tangent to an ellipse.